This is a video from section 5.5 found in a Calculus 1 class. The directions say to evaluate the definite integral. The examples will be taken from the Stewart Calculus textbook, 9th edition. So we're going to look at problem number 59. Suppose we're given the integral from 0 to 1 of cosine of pi over 2t dt. Now, what we're going to do is we're going to transform this entire integral in terms of another variable, which I will call u. And so I'm going to let u equal pi over 2t. So this is a substitution. du is pi over 2 dt. So if I solve for dt, I'm going to multiply both sides by 2 over pi. So I end up getting 2 over pi du. Now, when t equals 0, I'm going to come back to this substitution up top, okay? Because, again, these limits are in terms of t, and I want everything in terms of u, okay? So when t is 0, u is pi over 2 multiplied by 0, which is equal to 0. When t is 1, u is pi over 2 times 1, which is pi over 2. And so I'm going to take this 2 over pi, and I'm going to put it out in front of the integral, and I'm going to integrate from 0 up to pi over 2 of cosine u du. But this is 2 over pi times. Now, the antiderivative of cosine u is sine u. That's the function whose derivative is sine u. That's one of many, right? But we just need an antiderivative of cosine u. Now, I'm going to evaluate from 0 up to pi over 2. So this is 2 over pi times, I'm going to replace u with pi over 2, and I'm going to replace u with 0, and I'm going to subtract those results. So I'm going to get sine of pi over 2 minus sine of 0, but this is 2 over pi times 1 minus 0. So the answer to problem 59 is 2 over pi. Let's take a look at problem number 63. Suppose we had the following. So we're going to integrate from 0 up to pi over 6 of sine t divided by cosine squared t dt. Now, this one's a bit interesting because I'm going to rewrite this integral. So I'm going to make this sine of t divided by cosine of t times 1 divided by cosine of t. So this is one of those interesting ones where you really don't need a u substitution here. Could you do it with a u substitution? Yes, you can, but I'm going to submit to you that it's not necessary. Now, sine of t divided by cosine of t is tangent of t. 1 divided by cosine of t is secant t. So this is the integral from 0 to pi over 6 of tangent t times secant t dt. But directly speaking, this is secant of t evaluated from 0 up to pi over 6. Okay, the derivative of secant t is secant t tangent t. So if I replace t with pi over 6, I get secant of pi over 6. If I replace t with 0, I get secant of 0. And I'm going to show you guys what I think. Now, I look at this as 1 over cosine of pi over 6 minus 1 over cosine of 0. And if we come up here to the side, cosine of 0 is 1, right? Cosine of pi over 6 it's a special angle, and this is square root of 3 divided by 2. But we need the reciprocal. So this is 2 divided by square root of 3 minus 1. Okay. Now, your teacher will probably want you to simplify, so I'm going to rationalize the denominator here. And so I'm going to write this as 2 square root of 3 divided by 3. So all I did was multiply the numerator and denominator by square root of 3. And I'm going to subtract 3 over 3. 3 divided by 3 is 1. So the answer here to problem number 63 is 2 square root of 3 minus 3 divided by 3. So that's 63. Let's take a look at 67. Suppose I have the integral from negative pi over 4 to pi over 4. And the integrand is x cubed plus x to the 4th tangent x dx. So, a couple things. Recall. The integral from negative a to a of f of x dx is immediately 0 if f is an odd function. And you might ask, well, what does that mean? For f to be odd, it means if I take f of negative x, you're going to get negative f of x. Okay, so what I want to do is I want to take a look at this integrand. So I'm going to let f of x equal x cubed plus x to the 4th tangent x. And I'm going to look at f of negative x. So this is negative x to the 3rd plus negative x raised to the 4th tangent of negative x, which is negative x cubed plus x to the 4th. Now remember, the tangent function is an odd function. So I could pull the negative out and multiply by the tangent of x. And so if I take a negative out of both terms, I get x cubed plus x to the 4th tangent x, which is equal to negative f of x. And so therefore, f of negative x is the same as negative f of x. Therefore, the integral from negative pi over 4 to pi over 4 of x cubed plus x to the 4th tangent x dx is equal to 0 immediately. We don't have to do any substitution or anything of that nature. And that right there is problem number 67. Let's take a look at problem 71. Suppose we have the integral from 0 to a of x square root of x squared plus a squared dx. And there's a note here that a is greater than 0. So what we're going to do here is we're going to let u equal x squared plus a squared. Okay? So this is a classic u substitution problem. Remember that a is constant. That's key. So du is 2x dx. Now I'm going to take x dx and I'm going to solve for that. So x dx is 1/2 du. When x is 0, right? So again, we have to go to this substitution and find our corresponding limits in terms of u, okay? So when x is 0, u is 0 squared plus a squared, which is equal to a squared. And when x is a, u is equal to a squared plus a squared, which is equal to 2a squared. Now, I'm going to take this 1/2 here and pull it outside the integral. So this is 1/2 the integral from a squared to 2a squared of square root of u du. Okay? Now, this is 1/2 the integral from a squared to 2a squared of u to the 1/2 du. Now, recall the integral of x to the n dx is 1 over n plus 1 x to the n plus 1 plus c. And this is where n does not equal -1. Because if n is -1, we have division by 0, and you don't want that. Now, here, I'm going to get 1/2 times 1 over 1/2 plus 1. U to the 1/2 plus 1. Evaluated from a squared to 2a squared. Now, again, let's come off to the side. We're going to do a little side work here. 1/2 plus 1 is equal to 3/2, right? And so I'm going to take the reciprocal of 3/2. So that's 2/3. U to the 3/2 evaluated from a squared all the way up to 2a squared. Now, I'm going to get 1/2 of, and, well, yeah, we'll just stick to that. And then we're going to take u and replace it with 2a squared. So we get 2a squared to the 3/2 minus 2/3 times a squared to the 3/2. Like this. Now, I could also factor out the 2/3. That might make it a bit easier. So I'm going to take 1/2 and then multiply by 2/3. So we're going to factor that completely out. And then we get a squared. In fact, we get 2 to the 3/2 times a squared to the 3/2 minus a squared to the 3/2. But when you take an exponent and raise it to another exponent, you're going to multiply these exponents. And then the 2's cancel. And so we get 1/3 times the quantity. 2 square root of 2, right? That's the same as 2 to the 3/2 times a cubed minus a cubed. And so I'm going to factor out an a cubed. And you get, so what you end up getting overall is a cubed over 3 times the quantity 2 square root of 2 minus 1. And that's number 71. If we take a look at 75, suppose we had the integral from e to e to the fourth of 1 over x times the square root of ln of x dx. Now, one quick note here. The natural log of e is equal to 1. We're going to need that. Now, I'm going to let u equal natural log of x. So, one thing again I want to reiterate is we're transforming an integral from something in terms of x to something in terms of u. Okay? Now, du is 1 over x dx. Now, when x is e, u is natural log of e, right? So therefore, I'm going to say when x is e, u equals 1 because natural log of e is 1. And then when x is e to the fourth, u is natural log of e to the fourth, which is equal to 4 times the natural log of e, which is equal to 4. And so we're going to make this the integral from 1 to 4 of 1 over the square root of u du. And so this is the integral from 1 to 4 of u to the negative 1/2 du. But remember, negative 1/2 plus 1 is equal to 1/2, right? And so this is 1 over a half u to the half, right? I'm using the formula over here. So if we come back, I'm evaluating from 1 to 4. But when you take 1 over a half, that's 2. So this is 2u to the 1/2 evaluated from 1 up to 4. So this is 2 times 4 to the half minus 2 times 1 to the half, which is 2 times 2 minus 2 times 1. And so the answer here is 2. And that's how you do problem number 75. So let's take a look at problem number 79 to conclude this video. So on problem 79, we have the integral from 0 to 1 of 1 over 1 plus the square root of x raised to the 4th power dx. And so this one is a classic one in the sense that I'm going to let u be the square root of x. Okay? Now, I'm going to square both sides. So u squared is equal to x. So we got to get rid of that radical somehow. Now, dx is 2u du. Remember, you're trying to transform an integral from something in terms of x to something in terms of u. So when x is 0, u is 0. When x is 1, u is 1. So this is the integral from 0 to 1 of, now dx is 2u du. So I'm going to have 2u in the numerator. In the denominator, I have 1 plus u to the 4th du. We're not done. Now, I'm going to do another substitution. So what I'm going to do is I'm going to let w equal 1 plus u. dw is du. So when u is 0, w is 1. When u is 1, w is 2. So this is the integral from 1 to 2. I'm going to pull the 2 out in front. Now remember, if w is 1 plus u is w minus 1. Just subtract 1 on both sides. So I'm going to get a w minus 1 from the numerator, and I'm going to get a w to the 4th for the denominator. And now what you want to do is you want to split off that fraction. So this is 2 times the integral from 1 to 2 of w over w to the 4th minus 1 over w to the 4th dw. So this is one of those double substitution type problems. So this is 2 times the integral from 1 to 2 of w to the negative 3 minus w to the negative 4 dw. So this is 2 times. I'm going to get w to the negative 2 divided by negative 2 minus w to the negative 3 divided by negative 3 from 1 to 2. And we're going to come over here. So I get 2 times, I don't like negative exponents, so I'm going to make this negative 1 over 2w squared plus 1 over 3w cubed from 1 to 2. And so this is 2 times. I'm going to put 2 in for w, and I'm going to get negative 1 over 8 plus 1 over 24. And I'm going to put 1 in for w, and I get negative 1 over 2 plus 1 over 3. Just like this. Now, I'm going to write everything in terms of the LCD, which ends up being 24. So I get 1 over 24 minus, I'm going to rewrite 1 over 8 as 3 over 24. And then I'm going to distribute the negative in. So I'm going to write 12 over 24 minus 8 over 24. Like this. Now, 1 minus 3 is negative 2. Negative 2 plus 12 is 10. 10 minus 2 is, 10 minus 8 is 2. So this is equal to 2 times, now let's double check again. 1 minus 3 is negative 2. Negative 2 plus 12 is 10. 10 minus 8 is 2. So this is 2 times 2 over 24. And so this is 1/6. And that's the answer to problem number 79. And that'll conclude this video for section 5.5, where we worked on problems 59, 63, 67, 71, 75, and 79. Thank you.